Thank you, Ish. Thank you very much. Hi, everybody. Welcome to the graveyard shift. You've made it this far. Congratulations. Energy levels? Who's got high energy levels right now? Oh, winner! Who's got low energy levels right now? It's good. A few, I say a few. So my name's Derek. This talk has evolved over a couple of months, actually, out of me talking to developers and realizing that actually we don't know that much about observability. We've been leaving it to the people who run the machines, and that's wrong. So I put this talk together as a way of highlighting what I think, and it's my opinion, what I think developers should be aware of when we talk about observability and what happens to our applications once they hit production. So let's go. Who am I? If we haven't met before, I'm sorry, but my name is Derek, and I am a very old software developer. I have gray hairs. I have pushed many things into production, sometimes by mistake, and for that I apologize to those product owners. But I've been at AWS for about 6 years. This talk, when I talk about the technologies and the examples that I give, majority will be about AWS stack, because that's what I do. But the actual principles are applied across any stack at all. So please bear that in mind. When I talk about a service, I will tell you what it does. And so in your mind, think about, well, I know the service that actually does the same thing. So this will help you understand the principles and the things I'm trying to get at. As you can tell by the accent and the shoes, I'm actually originally from Ireland. And as I am Irish, Australian, I do like beer. I've taken up cycling because of the beautiful weather in Perth and where I live. And I am a big nerd. So here we are. We're in the graveyard shift. We need to learn something. We have probably about this much mental capacity left. We need to squeeze just this little ounce of knowledge into our engaged brains. So please, let's do that. And like any horror story, I'm going to tell you about a story that probably most of you are familiar with. This is a story of the front-end team and the back-end team. The front-end team building nice little React front-end UI that integrates with a back-end API, maybe via REST, maybe via Graph, maybe via SOAP. Oh my God, anybody remember that? And then receiving those lovely requests, it's the back-end team. And the back-end team pull those requests, do some back-end processing, send responses, write some batch jobs, do all the lovely stuff that the back-end team do. However, one day, a user phones up the call center and goes, I did a search. It's not coming back. Then I did another one. And then I did another one. And nothing ever came back. What's going on with this stupid application that I'm paying $70 a month for? And so this support desk gets in contact with the front-end team, who blame the back-end team, because their end, nothing's wrong. And then the back-end team go, front-end team don't know nothing. It's their fault. And so we end up in this flipping loop of finger pointing, and because we can't actually prove where the problem is. So how do we fix this? Observability. And as we adopt more and more testing in production as a thing, so observability and working out what's actually going on in production becomes a bigger thing. And so this talk is actually called Observability for Developers, or OLLI for devs, because if you want to be cool, observability is forever and a day now called OLLI. How do you remember OLLI? Anybody ever been a skateboarder? OLLI for devs. So what is actually the term observability, and where does it come from? Well, actually, it's quite an old term. When I say old, 60s. Invented by Robert Kalman. So he invented it, and I'm reading this bit, because it's the only bit of the talk that I can't remember. So in manufacturing engineering, Kalman's premise was that a system cannot be controlled or optimized unless it's observed. So to achieve that, we need to understand fundamentally what's happening in our system as it's exercised by our users. And when I talk to devs about Ollie, 9 times out of 10, they say, well, that's just monitoring. That's just telling me how much memory a Lambda function's using. Or that's just telling me how much CPU a VM is using. Well, actually, that monitoring is one piece in the puzzle of the observability, and that's why I call it Ollie, because observability is hard to say. It's one piece of the puzzle is monitoring, and the other pieces of the puzzle are tracing and logging. And together, they make up the observability trifecta. However, we usually don't call it monitoring. We call it metrics. And metrics is the thing that you measure, so CPU and RAM, and as a result, you raise an alarm going, bugger, this thing is above a tolerance that I expected. So I raise an alarm based on a metric. And then a log. Well, logs as developers, that's pretty much what we interact with. We write something out to console.out, log.info, log.debug, and it arrives in a log. And traces is how components in the system interact. So component A calls B, calls C, calls D, and we trace that flow through the application. So they are the 3 pillars. How do we remember those? Well, MELT. MELT is how we remember metrics, logs, and tracing. If, like me, you're a visual person, pink ice cream. Metrics, logs, and tracing, pink ice cream. So in AWS, purple doesn't come out really well in the sunshine. In AWS terms, metrics, logs, and tracing is these services. So CloudWatch metrics, CloudWatch logs, and X-ray traces. They're fundamentally how you implement MELT on AWS. And as you see, it's mostly CloudWatch. So here's a nerdy, I said at the start, I'm a bit of a nerd. Here's a nerdy metric on CloudWatch. So 9 quadrillion observations, more than 5 exabytes of logs per month. So the equivalent are 1 million observations per person on the planet per month. Think about that for a second. That's a lot of stuff. And usually when I talk to devs about observability, that's the face I see, because we're faced with a lot of different and competing services to solve the same problem. We want to observe our system, and we want to know what's going on, but we have a raft of services to do it. So I'm going to really simplify it. So when you're thinking about observability and the observability stack that you need, you have 2 options. You have outside-in approach. So this is thinking about the front-end team, where they are very much user-focused. The user behavior and how they track how users go through that front-end application is of primary importance, and so they start there. And I've identified some services to help that digital experience layer. So we have synthetics. So if you can synthesize what user behavior is, you're in a good spot. If you can also generate metrics from real user behavior, which is what CloudWatch RUM does, you're in a better spot. And if you can test, A/B test feature flags in production, and that's what Evidently does, you are in an even better spot, because what you're doing, you're observing new changes to the system before they're completely rolled out. Now, as you go down from digital experience, you're into application, and that's where you're more interested in X-ray and how different components of the back-end system interact. And then finally into infrastructure. So that's where you think about CloudWatch logs and what batch jobs are running, what of the back-end services and what they're doing. And you do that using logs, alarms, and metrics. And back-end teams really like dashboards to tell you that. Or the other way to think about it, and this is primarily if you're the back-end team, is the inside-out approach, because you're driven by those batch jobs or how quickly your database is responding to queries. That is how you think about it, and you think about and prioritize it from the other way, from the inside out. And why do you do that? Well, that's the next slide. So let's give you an example. So if you want from the front in, so the outside in, you want to make sure that your web page loads really quickly, your user's happy. You want to make sure that no purchases are failed, user's happy. You want to make sure that Java errors are at a minimum, everybody's happy. Whereas in the inside out, you're really thinking about slow queries on your database, integration health between services and back-end services, and how many times you're restarting your container. And why do we have these two approaches? Well, and what drives them? Well, obviously, it's what the business wants. In this, it took me a while as a developer to actually understand that I can write code, but unless it actually has a business benefit, it's useless. And so when you think about observability, those two approaches, whether you're outside in or inside out, are absolutely driven by what the business wants from the application. So does the business more a user experience focused thing, or is the business a more back-end performance-driven thing? So that's how you simplify how you think about your observability picture. So as I promised in the synopsis, I'm going to do an example. So this example is a serverless example, and I'll show you how to start your observability journey on AWS with a serverless example. Here it is. It's very simple. API gateway, Lambdas, consuming those requests, updating and inserting records in DynamoDB. And you'll have the out-of-the-box monitoring that you get on AWS. How do you start thinking about that observability? Well, you don't have to think about it. You can choose that option. And that's what I'm going to call vended melt. So this is out-of-the-box observability solutions that you get on platforms like AWS. And here's a list of vended metrics that you can look up, and there's the QR code. Please don't try and read this screen. Grab the QR code. And this will list all the services that are available in AWS and the metrics that they vend out of the box. You should understand this. Obviously, because this is the platform that you're running your application on, you need to understand it. No matter what platform it is, you need to understand what comes out of the box. I've taken an example. So this is a vended metric for Lambda. You can see here, it'll say what is the metric and what is the dimension. And you can read that as well. Again, you must understand that. If you're choosing to run Lambda in your application, read the doco, RTFM. Then vended logs. Here's the Lambda example of vended logs. And then vended traces. You just switch them on in Lambda. It's basically a checkbox. So I'm going to start the demo, and I hope you can see this as putting just the vended metrics in this application. Now, as I was up to 1 a.m. setting up Serverless Espresso, this is a recorded demo. I don't usually do recorded demos. So we've got product function. So this is the application itself. So it's got a DAO, so data access object. And inside there, we've got getters and setters, as you expect from a data access object. Then if we go into the product object itself, you've got the updates and handlers. In the handler itself, you've got all the Lambda functions. So you've got a request handler, and you've got a handler for all of the update, create, read, all the CRUD operations that you're going to do on this handler. Now, what I'm showing here is that I've got some logger.infos. So I've went, oh yeah, I need some logger.infos here. And also in the request handler, logger.info, the actual object that I'm pushing in itself. So this is additional logging. I, as a developer, have went, okay, I just need to log the object so I know what's going on. And so I'm showing you those. seeing that there's nothing special about this, and this is typical of what you'd write. Then if I deploy it, so you can see this is all deployed and exercised. So I've deployed it in the back end, and I'm now exercising it. You can see it's all deployed, and I can then look in the logs in CloudWatch logs. So if I click over to CloudWatch logs, go to logs, you'll see that there is quite a lot of logs already there for me. So they are the vended logs that are available with CloudWatch. So what you'll see is the input event. So I've went log.info, object that was passed in. So I've created that, and you get a lot of stuff because the object is quite complex. And then I also get the vended metric. So this is the duration. So I've got request ID, the duration that the Lambda executed for, and also, so what I can do is using the request ID from the vended metric, I can see the history of this request as it went through the application, and just by searching for it, which is fine. You know, it gives me some information about what's there, but it's all right. So this is then metrics. So this is metrics out of the box. So for Lambda, if I click in the metric itself, you'll see I've got stuff like, and I'll read this, invocations, some of invocations, the average duration, throttles, some of the throttles, and some of the errors. Now this might be interesting, but what's it showing me about my application? What observability is it giving me? And then finally, traces. So the last bit of melt, this is X-ray. So I'm showing you the trace ID, and I'm showing you how the trace goes through the application from the client to API gateway to the Lambda context into the actual Lambda itself. And this, again, a vended X-ray will show you just how it comes into the Lambda function, and it won't show you anything more than that. So notice there's no database in that trace, and also notice there's no mention of the different functions that were called inside the Lambda. So that's the vended metric. Is the vended metric enough? Only in demos. You, developers, need to use more than the vended metric. The vended metric is not enough. You need, and when you realize this, you then think, okay, well, what do I do now? Well, how do I fix this problem of increasing the observability in my application? The vended metric given by the the stack that I'm using isn't enough. What I do, and what you should be doing, is looking for the best practice tools for the environment you're running on. And so the best practice tools for serverless and increasing the observability of an application is Lambda Power Tools. So Lambda Power Tools is an open source stack that you can add into Lambda to increase its metrics, logs, and tracing. It's written in a number of different languages, including Python, Java, .NET, TypeScript, and it's really easy to implement and adds a lot, including things like embedded metric format, which I'll go into a bit more detail later in the talk, but also best practice X-ray tracing and how to really log efficiently without you thinking about it. So let's actually add custom melt into this application. So to add in Power Tools is simply a case of importing the version. Oh, I zoomed this one. So you might be able to see this one, actually. So importing the version, then importing the different aspects. So Power Tools implements, and the aspects of Power Tools are metrics, logs, and tracing. So I just pull those in because they're the things I'm interested in. And I do that there. And now that I've imported it, I could start using those aspects inside my functions. So if I move over to the product handler, which is my one and only function here, I can start going at logging and doing a different, doing logging events through my function. Now, why would I do this? Because I can remove all that code that I wrote. I don't need that. I don't need to log the object because Power Tools is doing it for me, and it's doing better. It's doing it a lot more cleaner, into a standard format. So I can rely on the format that ParTools is creating. I can then annotate as well the data access object. So again, every time I reach into my database to update or insert, it will log that too. And then I also can define the log level for ParTools itself. And so that's what I'm doing there. So what does that look like, I think is next. Yep, so once it's deployed, and we go back into logs, you'll see that the logs look completely different. And so rather than me passing an object into log.info and writing that, I'm actually using ParTools to give a consistent logging thing and feature to my application. So if I expand one, you'll see actually the entire message is coming through, right? So that makes that log information a lot more powerful, as well as it gives me such details, the epoch, seconds, memory size, is it a cold start or not, and also includes the X-ray trace ID. Now, there is some overlap between traces and metrics and logging, and I'll go into detail on why that is in a minute as well. So that is Lambda ParTools implemented in that. So now I can also use Trace ID as a better way of understanding the flow through the application. So what happens is before, you see on the left, so that's an object. So as you must think about, as you log objects, they're different. So it might be a different type of object, but with ParTools, it's going to be a consistent logging experience. So that's logs. Again, adding the other features of ParTools is really, really easy. Again, the same sort of idea where you add the aspect. So you can add metrics, and you can add tracing as well. So I'm actually going to skip the code because I want to get to what it looks like. So metrics then, this is a metric that you've injected into your application. So how many lambdas are cold started, and how many times a particular function is being called. So how many products are being updated is what I did here. And that gives you a lot, maybe the metric that actually makes sense to your business. And again, that's where you have to start from when you think about what am I going to log as a metric, or what am I going to trace. Now tracing, I'm adding tracing at a method level. So if you remember when I had the out-of-the-box vended metrics, there's no mention of the database and no mention of individual functions or methods inside my handler. So you can annotate those with tracing, so that allows you to actually really dive deep into what method is calling what inside your handler and being able to trace the ID through that. And so that looks like when I go into the actual X-ray console itself, you'll see that if I click into a particular trace, the trace itself, if I scroll down, you will start to see that there will be functions. So there, so functions and databases included in your trace. So this is all best practice implementation of X-ray using ParTools. And so if you, whatever stack you choose, find the tool that does this. Do not try and write it, because you don't have to. So then before, X-ray trace, and then after. A lot more detail, a lot more comprehensive. You've got a better insight and observability into what your application's doing. So when I first give this talk, a lot of feedback was, Derek, I don't do serverless. And I'm like, you missed the point. It's not really about the tool set. It's about the ethos. And so if you don't use serverless, you use OpenTelemetry. It's that simple. OpenTelemetry is the thing. So if you haven't come across OpenTelemetry, it is where you can have your application, you install your instrumentation. So it's an open source spec, so you can go in and see all the OpenTelemetry code. You install it on top of your application. It ingests logs and metrics and traces into a collector. So different terms for OpenTelemetry, but it's called a collector. You can also do an enrichment inside the collector. And I do apologize because the slides are purple. And then once the enrichment's finished, you can export that to whatever. So you export it to a backend collector. Now, again, that can be anything. The backend collector could be CloudWatch or it could be other third-party tools. And inside there, you can correlate logs, traces, and metrics. So OpenTelemetry is what you should be thinking about if you're not building a serverless application. Even with serverless, we have OpenTelemetry collectors that you can put into Lambdas. And we have a AWS distro for OpenTelemetry as well. Okay, so that is the tools. The next stage of this talk is all about the two terms that every developer needs to know when melting. So we've thought about the tools. It's now thinking about stuff that I've been talking to developers about, and they're like, "What's that?" I'm like, "Gee, you need to know this." The first one is high cardinality. So does anybody know what high cardinality is? Got a few. Usually in the database area, high cardinality is something that has a lot of different permutations potentially. So how is that important to observability? Well, here's an example. So we want to capture the metric, which is latency. Very important in Perth is latency. And with that metric comes a number, and I'll read the columns. So we've got request ID, we've got customer ID, and we've got the actual service. They are your dimensions. And the customer ID, the column 1, and the second ID, request ID and customer ID, they're very big numbers with some of them got letters in it. They have high cardinality. Why is that bad when we come to think about traceability? Let's think about a metric called HTTP response. That can have a dimension of either status code or environment. That could have potential dimension values for status code of 1xx to 5xx, so status codes of HTTP requests. And also environment. So environment can be dev, prod, other environments. Then we think about the cardinality that those dimensions can potentially give us. It starts to build out. So what was a simple HTTP response metric starts to give us high cardinality if we want to track it. Why is that important? Let's think about an old traditional system. So we have a VM environment. They want to track this HTTP response. We have two environments. We have dev and prod. We have 10 services in each environment, which have 5 status codes and 10 instances. So that gives us 1,000 possible metrics from those environments to track HTTP response. Now, most times in modern applications, we have a distributed application. So we have more than just the VM. We have a distributed cloud-native application that's running across many different services. So to track HTTP response, we could still have dev and prod, but we have 100 services running wherever. We have still the same 5 status codes, but we could have 10,000 tasks or pods if we're running on kubes. What does that mean? That actually gives us 10 million possible metrics that could occur across all of those, just to track HTTP response. And hopefully you're following along. In a VM, that'll cost you $300 a month. In a distributed cloud-native application, that'll cost you $250,000 a month. And this is another thing when I'm talking to developers about observability, is the figure. And they're like, "Oh, CloudWatch cost me a fortune." Yes, because you're capturing it with a high cardinality metric. So how do we fix this? How do we go to our next meeting and go, "I know about high cardinality, and I flipping know how to fix it too"? Well, actually, you don't use metrics or logs. You use both. And you use it in the AWS term is embedded metric format. So CloudWatch embedded metric format is a standard way of writing metrics in logs. And so think of it as an example. So we've got a telemetry, piece of telemetry here from two systems. We log it. We don't create a metric when the telemetry is created. We just log it. We put it in the logs, and then when it's consumed, say by OpenTelemetry, and we get it into our backend system, we can then create a metric based on that log. So we didn't have all of those metrics. We didn't create all of the metrics in the system. We only created the metrics that we actually needed, and the business is key to the business that they exist. So by putting them in the logs, gives us options that we can then create metrics down the track. So the TLDR of high cardinality is understand them. Understand what in your system can be a highly cardinal dimension. Ingest it as a log, and then as you need it, and as the business needs it, and as the application needs it, create your metrics accordingly. It'll save you time, it'll save you in false positives, it'll save you money. If you're using CloudWatch, use EMF, and also OpenTelemetry. Has an EMF exporter. Don't have to use EMF, but as long as the metric format that you're putting in the logs is consistent across the entire application stack. Okay, that's number one, high cardinality. Trace propagation. Anybody come across trace propagation? Oh, excellent, excellent. So hopefully we've still got some brain capacity, because this is the last one for the talk. This is a typical trace if you look in Amazon X-ray. You have the trace ID, which is how X-ray distinguishes the trace. You then have the root. So the trace ID for the X-ray trace. You then have the parent, which is the upstream segment ID. And I'll explain what a segment is in a sec. And then sampled, so how many samplings X-ray decided to make. So for example, if we have API gateway, so Lambda is the HTTP request, into S3 is an HTTP request, that is a trace, that really is a purple line. That is a trace. And so each trace is made up of what I'm calling here spans, right? So in X-ray, it's called segments. In OpenTelemetry, it's called spans. You see, it's the same idea. No matter what implementation you're using, it's the thing that breaks up the trace. So we've got a span for API Gateway, Lambda, and S3. And the overall trace ID itself is called 123. So the span ID for API Gateway is ABC. So that means that the trace ID is set to 123, and the parent ID is ABC. Then if we go, the trace goes on to Lambda, the span ID is DEF. So the trace ID is still 123, but the parent ID then becomes DEF. And that's how it works. It traces that application call through the trace by breaking it into spans or segments. So, it's great. But what happens if we're not using API Gateway, Lambda, and Dynamo? Say we're using Elastic Container Service, Amazon MQQ, and then into another Amazon Elastic Container Service. Then the span ID can be ABC and ECS. So the trace ID is 123. There's no parent because it's the first part of the trace. Then the trace ID, as we hit into Amazon MQ, becomes 123, and the parent ID is ABC because that's ECS. However, Amazon MQ does not propagate the trace. So we lose all history of what's happened because Amazon MQ does not propagate the trace. So what happens is in span ID DEF, the trace ID is new. So it's 436, not 123, and it has no parent ID. So we actually think it's a new trace, which is completely useless because it is not a new trace. It is a flow through the application. We just haven't catered for trace or lack of trace propagation. So not all services are equal. and not all services propagate the trace out of the box. And so to find out what services do, there's the link. Here's the list of them, probably 6 months old now, but this changes. Again, you must understand this. You must understand what services in your stack do trace propagation and which do not. So what do I do when a service I'm using does not propagate the trace? Oh my God. You get a better predictor. So what you do, you actually write it in code. So in the consuming service, so this is an example of something being sent into a queue that doesn't, the service itself, the queue service does not do trace propagation. What you do, and what that code is showing you, is you use the trace SDK. So if you're using OTel tracing, there's an OTel OpenTelemetry SDK, and you put the span information inside the actual body of the request as you push it into MQ. Then, when the message gets out the other side, you pull out that information about the span that sent the message, and you recreate the trace. So you put the information in a new instance of the span. And that way, you maintain the history of the trace, because you know about trace propagation, because you've listened to Derek talk about it, and now you're a better developer. So the TLDR of trace propagation is instrument all your code. Makes sense? Understand which service supports tracing and how. So there's an underlying theme here. Observability is all about understanding what you're running on, which should be a thing anyway, but sometimes it's not. If a service does not support tracing and trace propagation, pass the trace content across the service boundary. The SDK will do that for you, so that the tracing software that you're using that has an SDK that will do that for you. And then resume the context on the other side of the service boundary. So you push a message out, you consume the message, you keep going. So the final section of this talk is all about how is Ollie evolving. So Ollie has been around, as I said, from the 60s with Robert Kalman. As we evolve and as we evolve our computing thinking and our application thinking, Ollie itself is evolving. So Ollie traditionally was reactive. So it was alarms, things happen, you fix them. Now, and the way computing is just evolving throughout the entire stack, it's being proactive. So we rely on the old AI ML, and I swear this is the only time I will mention it in the talk. We rely and more on models and machines to proactively predict when something is going to fail. And not only that, we proactively predict what security vulnerabilities are in your code before you push it to production. We predict how many bugs you've injected into your code before it pushes into production based on the history of your bug creation. And we also predict, and this is an example, is anomalies inside your application as it's running. And we do that. It's a very simple statistical algorithm. We capture how your application is run successfully over time, and then as it runs in the future, if it goes over the boundaries, then an alarm. So we're predicting when it's going to fail. And that prediction thing is how I see observability and Ollie changing over time, and we'll see a lot more of that as this AI, ML, and Gen AI trend continues. So if you want to learn more about observability on AWS and the tools that you can use, we've got a workshop that you can run on your own independently, which will go through pretty much every single service that you can use for observability on AWS. We also have a specific workshop for OpenTelemetry. So as I said before, OpenTelemetry is the standard for observability, no matter what stack you're running on. So there's a workshop on how to implement that on AWS. And then there's also a skill builder course. So thank you to all the sponsors I work for AWS, so we have a coffee cart. We're giving away a PS5. I hope you've all entered because your odds of winning are quite high. And yeah, thank you. And thanks for listening. I hope I haven't sent you to sleep. There's a few yawns. That's okay. But if there's time for questions, I can take a few.
Absolutely. You've got 5 minutes for questions.
Yeah. We have a question from Mr. Nixon on the front.
Come in.
Mr. Nixon used to be my graduate.
Hi, long-time
Hello.
listener, first-time caller. How, especially with clients that you may be building software for who are very thin on the ground with staff, which is why they've hired you to build their software, how do you balance noisy patterns and them calling you and saying, I found an error? For example, your screenshot you had up before, when you added extra telemetry, it immediately had some 500s.
Yep.
Now, they would probably just call us and say, oh, it's an error. But
Yep.
how do you balance that as a best practice to not just get phone calls in the middle of the night about nothing?
Yeah. So again, it's excellent question, sir. So it's always the conversation at the business that we're not having. So when you do something like a metric, so a single metric on its own, like CPU is 100%, if that appears and flags and the business goes, oh, that's terrible, actually on its own it's redundant because it doesn't mean anything. But combined with multiple metrics, it can actually mean something and it can be impacting their business. And that's the things that you need to sit down and go, okay, if this happens, this is important. This is just noise. This is important. You need to have that conversation. If you're not having that conversation, yeah, they're going to try and pick holes in logs, which are completely irrelevant. It's all about the business value that you want to alert and alarm and show based on what they think is important. So it could be user behavior. It could be batch jobs on how long they take.
Thank you.
Christian. Hello.
Thank you, Derek. Do you have any guidelines or principles for how long this telemetry should live for?
That is an excellent question. So again, how risk averse is the customer that you're building this telemetry for? If they only care about the last week, it makes sense. Again, it's up to what is the business value of losing that telemetry after a month, 6 months, a year? Obviously, as you know, you have to trade it off against cost. And so you need to, there's obviously going to be a break even where the cost of maintaining the extra telemetry data outweighs the business risk and the business benefit of losing it. And that's the conversation, again, that we need to have with the business.
Thank you, good talk. So,
Hi, Tom.
like you mentioned, the machine learning things, we use that to predict what will happen. And now, like you have more and more machine learning applications, which actually bring some challenge for the developers, like how you kind of check the observability for the machine learning or AI applications. Do you have any like experience or best practice to share with us?
Yeah, I have strong opinions on Gen AI and the benefits that it'll bring to developers. I actually don't think that using something that generates a ton of code with no recourse is a good thing. You need to understand the code you're generating. So I would not build a production system using generated code from an OpenAI model, or not an OpenAI model, a Gen AI model. I just wouldn't do it. It's too risky.
Thanks for the talk. That was really awesome. When you were talking about melting, my brain went to the planet melting with all those logs going into CloudWatch. Is there a thought about, it feels like there's potential for us to go crazy with observability and be logging everything and
Exactly.
everything. How do we contain it, and how do we ensure that we're usefully logging stuff and not just logging everything?
Yeah, so it goes back to the start of the talk. What drives your business? Is it inside out or outside in? That's where you need all the observability coming out the wazoo, because that pays the bills of you building the code. That's where you concentrate. The rest you can do almost an arbitrary amount. But if the bills are paid by that part of the system, you need to implement it, observe it well.
Hi, great talk. You mentioned Power Tools. What do you get out of Power Tools over OpenTelemetry?
So Power Tools, as you've seen, it's really easy to implement. And it's built with Lambda in mind, right? So if you think about it's the consumption of compute, if you implement Power Tools inside your Lambda, it's tuned to run, whereas an OpenTelemetry collector may not be as efficient. So that would be the main difference. It's built with that native Lambda context, whereas OpenTelemetry, it does everything.
I had is that compatibility with other Appum toolings like Datadog and Sumo Logic, because you're going down this route.
Yeah. So your stack must be serverless. It must be serverless native to use Power Tools. And yes, you get all the benefits of serverless native: quick, fast, go to market, open, and adding Power Tools on that builds into that ethos. But really, if you're using an application or building an application and you've got a lot more time, then OpenTelemetry is probably a better way to go because you've got different hops, different parts of your stack, things that you can use that don't support Power Tools. So we use OTel.
I'm really sorry, that's all we've got time for. Hopefully Derek will be hanging around.
I will be here with beer. So please ask me and reach out. You know her there. Okay, thanks.
Give it up, Derek.